In the last video in this series, I made a video on sets and probability. Today I'm going to be making a video on sets and functions. So functions are a really important part of learning what sets are and their applications, so that's why I threw this in there. And I assume that you guys already have a good understanding of what functions are from your algebra class, but I just want to solidify your understanding to the more firm, rigid mathematical view of functions instead of just the, like wishy-washy high school point of view. So let's just get straight into it. So first, let's just begin by thinking of functions as mappings from one set to another. And I hope you guys can understand that. So like x squared, you start with some real numbers and then you end up with some positive real numbers, or zero, of course. So you're taking things from one set to another. And so let me just draw a picture. So we have one set. Actually, let me make that a little larger so we can work with it a little better. So we have one set here, and then we have another set here. And so I'm going to call this set A and this set B. And then our function is going to be f, and I'm just going to, and you can think of, arrows and stuff. We actually use arrows a lot with functions. And so we're taking things from A, mapping them to B. That's basically what's going on here. And a compact way to write that is that f takes A and sends it to B. Or let me write that B a little better. So that's like one way we can write this relationship, that you take elements from A and map them to B. And I'm gonna give another a few more pieces of notation and stuff later on throughout the video. But that's our first piece of notation. And I'll describe what these are exactly in a second, but actually I can do that now. So you commonly know this as the domain, and this, you may think of a word, you might think of it as range. Not quite, not always. In high school, yeah, that it works, but not always. So in general, this is what's called the codomain, okay? So basically, f takes elements from the domain and map them to the codomain. So I'm going to explain the difference in a second. But basically we can think of taking some element, I don't know, x, and then mapping it to some element y. So I'll just draw like a dotted line here. And we have this relationship where f of x equals y. And that's something you commonly see. Another same way to write this, just an equivalent statement, is f takes the element x and maps it to y. And with this arrow, notice the difference between the arrows. This one has a little tail at the start of it, so just keep that in mind whenever you're writing these relationships. But you're totally fine to use this. The reason to use this is if you want to be more explicit about how, because it looks like it's like you're taking x and then sending it to y. That's kind of the meaning behind that. Whereas here it's just like, oh yeah, you apply f to x and then you get y. Here it's like you take x and then send it to y through the function f. Sometimes you even write it as like something like x to y through the function f. I don't know. I prefer this, and these two are more common anyway. This you can write it, but it's not too common until you get to like higher mathematics. But you don't have to worry about that for now. And so yeah, so you have the domain-codomain relationship and the relationship between elements in the domain and elements in the codomain. So evidently, the domain and codomain are important things about functions. And in fact, they in part define the function. So for example, if we have something like f of x equals x squared, so this is an example, then this is only one part of the function called the rule. This x squared part, that's the rule, okay? And again, you can write this as f takes x to x squared, but so that's called the rule, okay? The other two parts you need are the domain, and the codomain. And with these three things, now you have a function, okay? Because this by itself doesn't really say anything, because it's like, okay, I know what to do with things, but I don't know what things go. is this all real numbers? Is it just positive real numbers? Is it just integers, natural numbers? Is it just the number 1? I don't know what to put in without the domain. So let's say my domain is the real numbers, which is a common choice of domain for this particular function. So now I know exactly what I want to put in. Any real number that I can think of. No complex numbers, just real numbers, okay? And then my codomain is what I get out. But we don't necessarily, it's not, like once we have the domain, I feel like those are the two most important pieces, because then we can figure out what the codomain is later, but we still put it, it's still a necessary part. And you can choose kind of what it is, as long as whatever we choose contains everything here. So I could say let's say, let me write it in set builder notation. So it's going to be all f of x's such that x, actually all f of x's in the real numbers, such that x is greater than or equal to 1. Okay? Is this valid? Well, not quite, because I said that the real numbers are, the domain is all the real numbers. Here I'm kind of just like not, it's not working. So, or even if I said something like, I could say something like f of x in R such that f of x is, I could say f of x is greater than or equal to 1. This is even worse, because now I'm saying like, okay, now I'm restricting the y coordinate basically. And we can't do that because there are certainly things that are between 0 and 1 that are part of the output set. So yeah, this just needs to be greater than or equal to 0. And that's fine because the outputs of x squared are positive numbers and 0, and this is precisely that. I could even say that they are greater than or equal to -1. Sure, there will not be any outputs between -1 and 0, but it doesn't matter because it as long as we contain everything that's supposed to be there, then we're good. So our codomain, we have a choice with that. And so let me just write this in a more compact notation. So I could even say all real numbers because yes, even though we don't map to the negative numbers, you could still include them. So I'm just going to say the real numbers. So in this case, f is a function that maps R to R. And I wrote there f of x equals x squared, but we can also write f takes x and maps it to x squared. Just like that. So those are our two relations, the codomain, like the set relation and the element relation. Okay. So now I want to discuss the range. So the range is, actually before I get there, it's kind of like a special case of what I'm going to call the image. So the image is if you take some subset, I'm going to call this C. Okay, this is a subset of the domain, and I take this particular subset and I see what you get out. And so let's say it's something like this. Okay, so I'm going to call this f of capital C. And yes, this is a set that is f of capital C. So what this means is f of capital C is our image. So if we have something like this, if f is a function that maps from A to B, and C is a subset of A that could be equal to A, let me write that a little better. It could be equal to A, but it doesn't, we'll talk about that in a second. Then f of C is what we call the image. So the image of C under the function f. Okay? So we take C and then we map it to f of C through the function f, and this is like the outputs of that particular choice of like the restricted domain. That's like a subset of the domain. We see what we get out from that. And that's all the image is. Now, if C is equal to A, if that subset is the entire set, then we in fact get out B. The smallest choice of B, if B is like the smallest codomain that we have, because we talked about that. But then, so that brings up something important. if, so let me kind of do like a little continuation of that. If C equals A, or just basically we can say, oh, actually, let me write it this way without using C. If we have F that maps from A to B, again, then F of A is the range of F. So this is the range of F, okay? It's the maximum possible, or the smallest possible codomain. So I'm going to put smallest codomain. And I hope you can kind of understand that, where that's coming from, because if I take all these elements and I map them, I see what I get out. It might be all of B if B is our smallest possible codomain, but if B is bigger than that, then it's going to be like a portion of B, a subset of B. So if I take all of A, map it to here, then I get what's the range. And that's why you typically hear the word range in high school, because that's typically what you're dealing with. You don't really, whenever you have a question that asks you, what's the range of F? You're looking for the actual ranges, because if you just said what's the codomain of F, and you have a function, let's say x squared, you could say, oh, it's the real numbers. But, you know, whenever you're asking for the range, it would just be the real numbers that are greater than or equal to 0. So I hope that makes sense. There's a lot that goes into that. And now one more thing I want to talk about is the pre-image. So same thing, it's the pre-image of a set under the function. So if I take, I can kind of reverse the roles here now. If I take some element or some set D, then this is what's called F inverse of D. And so D here is F inverse of D is the pre-image. And it's the same thing where if you take F inverse of an element, it's the inverse function. I hope you guys know that, or you're familiar with that. And so it's the same sort of thing. So if we have F mapping from A to B, and then here we have D is an element of B, our codomain, so D is a subset, or not an element, a subset of the codomain, then if we have F inverse of D, it is the pre-image. So let me write that. The pre-image of D under F. And so yeah, that's basically same idea. And then here, let me just say F inverse of B is the, actually there really isn't any sort of like pre-range or anything. So let me just actually get rid of that. So let me just write some specific definitions now. So we had F mapping from A to B. We have C is a subset of A, and then D is a subset of B, where A is the domain and then B is the codomain. So subset of the codomain, subset of the domain, subset of the codomain right there. All right. So then what we have is, if we want to know what f of c is all f of x's in B, right? Because remember, this is f of c was this guy. So it's all the f of x's in B such that x is in C. And then f inverse of D is all x's in A such that f of x is in D. I believe that, yeah, so for all f of x's in D, then we have all the x's in A that satisfy that. So these are some precise definitions if you are curious, and that's just in general for any set. So let me just, there we go, whatever, good enough. But yeah, so that's basically all I wanted to say about these. I didn't really give too many examples, but I think you can kind of see from the one example I gave of f of x equals x squared. But yeah, I hope you guys enjoyed. Thank you so much for watching, and I'll see you in the next video. Bye guys.